Deriving the equations of motion, that is, equations of uniformly accelerated motion. And in my previous videos, I defined acceleration as the velocity change of a body over the time taken for the change. That is, if a body must accelerate, its velocity must change with time. So when a body moves with a constant velocity or constant speed in a straight line, its acceleration is zero because the velocity does not change in the case of the body moving at a constant speed. So for a body to accelerate, its velocity must change with time. That is, must go from one initial value to a final value. Let's say a body initially is moving the speed of 30 meters per second, and after 2 seconds, the speed changes from 30 to 40. You can calculate the acceleration of the body by finding the difference between the velocities divided by the time taken. So when we say a body has a uniform acceleration, a constant acceleration, the velocity change with time, the rate of change of velocity with time of the body is therefore said to be constant. And here we have about 5 equations. We call them equations of uniformly accelerated motion. So the first equation has this: the final velocity equals initial plus acceleration multiplied by time. And then you can see the second equation of motion. And then this one is a follow-up, of this. This and this, you can call them equation 2 because just a slight difference between this equation 2 and 3. Then the next equation is this equation v squared equals u squared plus 2as. And then the last one is distance or displacement equals average speed multiplied by time. But I need to define the terms in this equation for those of us that have not been following my video lessons, because my previous videos have defined all these terms. But let's just quickly look at it. We say V is called the final velocity. That is the velocity of a body after some time t. Then U is called the initial velocity. The initial velocity of the body is the velocity of the body at t equals 0. That is at the start. Then S can be called the distance. We can call that the distance traveled or the displacement of the body. Then we call t the time in seconds. Okay, I need to give the unit of this. So final velocity is meter per second, and the same thing applies to initial velocity, meter per second. Distance or displacement is in meter, and time in second. And A is called the acceleration in the unit, meter per second squared. Okay, quickly we shall go through the derivations of these equations one after the other. So I want to start with the first equation of motion, V equals u plus a multiplied by t. Now we define acceleration A. To derive the first equation, we said acceleration A equals velocity change in velocity over time. Now that's a symbol that looks like a triangle is a symbol for change. So that gives me final velocity minus initial velocity divided by the time taken. So this is how we define velocity change or the acceleration of a body as this difference in velocity over time taken. So when I cross multiply, I'm going to have v minus u equals the product of a and t, at. So when I take this minus u to the right hand side of the equation, I have v equals u plus at. That gives the first equation of motion, v equals u plus at. Now for the second equation of motion, x equals ut plus half at squared. I need to start from equation 5. I want to take equation 5. And how do I arrive at equation 5? Okay, I'll show you that later. From equation 5, we have average total distance equals average speed u plus v over 2 multiplied by time taken. So the next thing we do here is to substitute for v. That is, substitute v equals u plus at in the place of v here. So, which means I'm going to substitute equation 1 in 5. So I'm going to have s equals, what's my u? Okay, what's my v? V is u plus at, that is from equation 1. V was equal to u plus at, so I replace this v with that, divided by 2 times t, so that I have s equals, this is u plus u gives me 2u plus at divided by 2 times t. Okay, so we can expand this bracket using the time t. So when I expand the bracket using the time t, I'm going to have s equals 2ut plus at squared, that is divided by 2. Okay, so we have that divided by 2. So we continue from here. Now, so that we now have, from the last equation there, I have s equals 2ut plus at squared divided by 2. Now, these two will divide the two terms on the right hand of the equation. That gives me ut, that is 2 divided by this, plus 2 divided by at squared will give me half at squared. So this is equation 2. Now, instead of substituting for v, that is equation 1, for v in equation 5, if I substitute for u from equation 1 again, from equation 1, I have v equals u plus at. If I make u the subject of this equation, I have u equals v minus at. Okay, by the time I substitute for u, substitute the above equation in equation 5 again, I have equation 5s equals u plus v over 2 times t. Now, by the time I replace this u with v minus at, I'm going to have s equals that becomes v minus at plus this v divided by 2 times t. Okay, so that I have s equals v plus v gives me 2v minus at times t over 2. Okay, so we have this. So that if I move to the next page to continue, we have the displacement of the body s. The displacement s equals 2v minus at times t divided by 2. Expand the bracket, I have 2vt minus at squared divided by 2. That is equal to my distance or displacement. So that my distance s equals, that's dividing this vt minus half at squared. So that gives us the third equation, or equation, the follow-up of the equation 2. Then to derive equation 4 quickly, from equation 1, we have v equals u plus at, and then squaring both sides of the equation 1 rather, squaring both sides, we have v squared equals u plus at. I'm going to place this in a bracket and then multiply and then expand the bracket. This is the same thing as u plus at multiplied by u plus at. So by the time I expand this bracket, I'm going to have v squared is equal to u times u, that gives me u squared, plus this is uat, that is u times at, plus 80 times u gives me uat, then 80 times 80 gives me a squared t squared. That is, if I multiply at by 80, it gives me a squared t squared. Okay, there's something I'm going to do here. Okay, let me write this first. V squared equals u squared plus this should give me 2uat, then plus the last term a squared t squared. Okay, so that is if I add this to this, so that by the time I I want to repeat this equation, that gives me v squared equals 2u v squared equals u squared plus 2uat plus a squared t squared. Okay, so that I will write, I want to factor out 2a from these two terms. From these two terms, I want to factor out a, or factor out 2a from these two terms. So when I do that, I have 2a equals what is left here, ut plus what is left here, at squared divided by 2. Okay, I'm sure you've seen what I've done there. This is v squared, this is u squared. From these two terms, this is 2u at, this is a squared t squared. I factor out 2a. If you bring out 2a from this term, what is left is ut. Then from this term gives you this. So that this is the same thing as equation 2, which is, well, that we derived that already. That is ut plus half at squared. So that is equal to my distance. My distance was ut plus half at squared. So that by the time I replace that, I'll have finally v squared equals u squared plus 2as. So we've gone through the equations of motion. V squared equals u squared plus 2as. So next video we shall attempt to solve a number of questions from these four equations of motion.